Control, randomization, and replication are the three principles of a well-designed experiment. When an experiment is created, we want to optimize these ideas. Control implies that we're trying to reduce the impact of potential confounding variables that may or may not be lurking. It can be difficult to eliminate confounding variables in real life. For example, if we were testing which car gets better gas mileage and decided just to run cars on drums in a lab, we have a situation that lacks reality. Yes, we get rid of factors on roads like stoplights, potholes, traffic flow, weather, etc., but what's left is an absence of realistic factors. We would only be able to generalize our results to cars that drive on drums in laboratories. So the challenge is to preserve realistic conditions but use the techniques in this unit to avoid confounding variables. With cookies, it was as simple as making sure we had an ample number of treatment groups to differentiate between times and between temperatures. For gasoline mileage, we learned a block for the size of a car, and for testing gas mileage, we should have cars drive at the same time and on the same route. Randomization gives us a more representative sample in each treatment group, provided our control was good. It eliminates bias on the part of an experimenter who might want to sneak a few more economy cars into the treatments receiving his favorite gasoline. The more abstract benefit of randomization is this. Suppose a county wanted to determine which trees would grow best in parks within the county. They could randomly assign 12 of each type tree to a plot in various parks and measure the growth after 1 year. They may think that certain plots of land are more advantageous and attempt to control for that using a block design, but there may be several plots of soil that look fine on the surface and actually have significant nutrient-poor soil. By randomly assigning the trees, randomization reduces the impact of this unseen factor. Theoretically, just as many of each tree should be randomly assigned to the bad and to the good soil. So a significant benefit of randomization, in addition to eliminating experimenter bias, is to help reduce the effects of lurking and confounding variables that might not be considered. Replication does not imply redoing the experiment. It suggests that we get as many units or subjects in the treatment groups as possible. We learn later in the course, and many of us have a sense of this already, that the bigger the sample size, generally the more accurate the results. It cuts down on random chance fluctuations, standard deviation, and allows us to more easily determine a statistically significant difference between parameters when a difference actually exists. So when assessing an experiment or designing an experiment, keep an eye on these three principles and be able to articulate their benefits.